Good day. My name is Bill Friedman, and on behalf of Appcito, I'd like to welcome you to today's webinar, How to Slash Cost and Complexity versus vsHAProxy, NGINX, and Amazon Elastic Load Balancer Solutions. Agility and cost savings are driving adoption of cloud infrastructure and microservices architectures. You know it, and we know it. But how do you ensure that the agility and cost savings are optimized across your whole stack, including application delivery and load balancing? Today, we're fortunate to have Dosanjh, Appcito's Senior Director of Solution Architecture, to step us through a customer application delivery infrastructure transformation. He'll show us the path they took to reduce their Amazon Web Services EC2 instance count, the number of vendors in their solution, the complexity and labor involved in keeping things running. And he'll show you how the resulting infrastructure is both simpler and facilitates agility. And finally, he'll show you how to apply these principles to your own public, private, and hybrid cloud infrastructure. Now it's time to introduce today's expert presenter, Dosanjh, Senior Director of Solutions Architecture here at Appcito. Das is a hands-on technologist. Over his 20-year career in information technology consultant, he's built, secured, managed enterprise-grade and web-scale infrastructure, working with organizations across government and retail, healthcare, financial services. Das has led projects that included things like a SaaS-based security solution for cloud applications, spanning Salesforce, NetSuite, ServiceNow, Gmail, Office 365. He built out a global content management and content delivery solution. And another interesting project is he secured cloud application data at rest and in motion with data encryption and tokenization. Also, during Das's career, he was a member of the founding team at Blue Coat, where he contributed to the design and success of their commercial-grade proxy software. At Appcito, he's working with our customers to provide scalable architecture to map their business application requirements to a workable solution. And with that, I turn things over to Das. Thanks.
Thank you, Bill, for that introduction, and thank you all for attending today's webinar. I think you'll find the information that we're going to share with you very exciting, very useful, and I think it may afford a new way of looking at things, of how cloud applications are introduced and how they're scaled across multiple environments. So as an introduction, I want to share a few thoughts around Appcito, how we got started, the team, and the value proposition that we provide. The company is a few years old. We're VC backed by the Fabric, Atlas Ventures, and March Capital Partners, I should say. And we have some seasoned veterans who have been in the Valley in various technological disciplines, from security, from load balancing, to infrastructure, to scale, as well as cloud-based applications. And the value that we're looking to provide is to really focus on cloud applications, how you scale and make them available, how you secure them, and provide some insights using the analytics that are gathered when you have cloud applications. And what the objectives of this webinar is to really show you how to simplify some of the complexity. And we're going to focus on the Amazon Web Services Cloud and show you how in that environment you can really simplify things as far as how traffic is then routed, how it is inspected, and how it actually then an application responds to it. We're going to show you how to reduce costs and slash those costs quite significantly. We'll touch upon that. Then how do you have an overall strategy, and how do you succeed with introducing new services with this new cloud application delivery approach? So that's the objectives, and we're going to step through a couple of themes as we go through this webinar. And those themes are based upon complexity, agility, and cost. And essentially, what we're seeing as one of the top challenges is there's a lot of fragmented software solutions in the marketplace, and they are a good introduction to some base level functionality, but they lack a lot of the advanced functionality, the ease of use, some of the manageability that you would expect as you start to take more of your mission critical applications into a cloud environment, and you expect enterprise grade kind of services and quality and nuances of how you manage, control, operate, and then obviously upgrade those kind of capabilities. So we'll touch upon those three themes: complexity, agility, and cost. And let's dive into the first one, which is complexity. So as I mentioned, we're going to look at the a very high-level architectural view of an AWS environment. And in this example, I've got two applications, a WordPress instances and Magento instances. So you're running in two separate environments within Amazon. And at the bottom, you'll see that we have various endpoints, whether it's desktop, mobile, or other type of sources of input that have their requests routed to a Route 53 DNS resolver, and then the traffic is forwarded to the applications themselves. On the right-hand side, I've just depicted server analytics for that application, so you can kind of get a sense of how that application is responding. So those are the essential baseline tools that are available for client request and server response. As things have evolved in the cloud over the past decade or so, we've seen folks introduce the Elastic Load Balancer from Amazon, which is part of their portfolio. And essentially what folks have done is introduced SSL termination or offload at this initial inspection point. And with the layer 4 load balancing, it's essentially routing traffic based upon the type of request to those backend servers. You also have a notion of CloudWatch analytics that can then tell you the health and the response time and the performance of those what we call ELBs, or Elastic Load Balancers. As things have evolved, as applications have evolved, there's been a requirement to introduce more capabilities in addition to low-level load balancing and SSL offload. And you've got a really good introduction of open source software and tools from NGINX and vsHAProxy that have been in the marketplace for a while, and they've done a really good job of providing layer 7 kind of functionality. So you could have just an NGINX only or vsHAProxy only, or they could be front-ending each other. It really depends on your architectural approach and the application requirements. And in addition to that, you have performance analytics. So that's a set of, you can say, HTTP-specific analytics on how URLs are being parsed and then forwarded to the backend applications. As we're all well aware, in this day and age, cybersecurity, cyber threats are pervasive around the globe, and they take various shapes and forms. Even though the enterprise architecture is controlled with firewalls and other layers of security gateways and other things, in the cloud space, the introduction of web application firewalls specific to the web application themselves to inspect, to control, and then do some kind of a processing on the type of traffic. If it was deemed to be a threat, what do you do with it? Do you quarantine? Do you delete? Do you archive? There's a whole bunch of actions that you can respond with. And these web application firewalls were specific to that application. What you'll notice here, as we're building these layers, these are specific to each application. So the WordPress application instances get their own set of fragmented solutions, as well as the Magento application. They get their own tier of solutions. As in any case, there's always dashboards involved to kind of get a view of what's taking place in real time, both threats, both responses, what kind of codes are being returned, and then what's actually happening on the wire. One of the benefits of using an ELB solution within Amazon is you can have this notion of application autoscaling. So this is a really key feature within AWS. As you can imagine, as traffic spikes are incurred, especially in the holiday season, you have a lot of e-commerce sites that may get promotions that are made available. And you want to take advantage of the autoscaling capability within AWS. So that essentially means if you've got a CloudWatch analytic, a threshold defined, let's say CPUs reach 50%, you want to start autoscaling the application servers so they can then service that traffic without making services unavailable, without response times being compromised, and essentially may meet SLAs that may be in place, especially if you're dealing with financial apps or healthcare apps or other types of industrial applications. So as you start to look at this, I've depicted an architecture for two applications, And you can see that the multi-tier, multi-layer, if you will, the multiple dashboard and analytics previews that are in place, and that causes a challenge of how many instances you actually have to have in place as you start to address the increase in traffic and the increase in users. And as you start to look and map that application specifics to the lower load balancers and the proxies and the other auto-scaling components, you have to do a multi-touch to each one of these instances, and that really leads to a fragmented approach of how you deploy these products, how you manage these products. And that lack of integration, both on the product side as well as the visibility of the insights from the analytics and the dashboard, really leads to a very complex environment and a very hard to maintain situation for the development operations teams, for even the application teams that want to take advantage of web scale solutions. And that is really a complex challenge. And we've seen a lot of our customers approach us and say, is there a better way to reduce this complexity and have a better way of servicing these applications? So as we looked at that challenge, the team here at Appcito said there is a better way. You know, we have teams that have evolved both from the enterprise and cloud space, as I mentioned earlier. And so what we've introduced is an application delivery system, ADS for short, with a sense of providing these capabilities and services to two audiences. The top audience that you'll see there is enterprise IT and the security teams. What they really want is consistency for their compliance and their regulations. So whether they're introducing agile services, whether they're introducing security components, whether they're introducing a single dashboard, they want to have that consistency of policy. And what we've provided them is this cloud services controller that allows you to centrally configure policies. You can actually integrate this cloud services controller using the REST API with other portals or other tools that you may have to define policies. And then it's a one-stop shopping for the analytics, essentially dashboards for what is actually transpiring with that application. And we've identified this upper layer as the control plane. So everything that you have to do with management, orchestration, and integration with other tools is done at this level. With the businesses that are now looking to migrate their applications or create cloud-native applications or even update and patch their applications, there's a whole notion of a development operation or network operation teams that have to come in to be involved. What they're essentially looking to do is change some policies, change some proxy settings without re-architecting the entire solution. That's a key thing right there. So we have this cloud services proxy that can live in Amazon or in other clouds, and they offer the advanced functionality of load balancing, security, and the analytics, all within the cloud services proxy. And customers have asked us, does this support their notion of microservices? They're looking to take advantage of some of the new capabilities in cloud environments, and this architecture allows them to actually move into a microservices architecture and approach where their applications can take advantage of some of the flexibility with applications being in multi-environments, multi-zones. And this web scale approach allows them to then take advantage, not only within Amazon, but they may have lines of businesses that have applications residing in other clouds. And so this application delivery system can reside in VMware, Azure, OpenStack, just to name a few, and then you can have a centralized view with the cloud services controller. So let's take a look at how that all fits together when we compare it to the current solution in Amazon with a fragmented, multi-layered approach with a bunch of tools, and how we actually support that in, again, within Amazon, but using the ADS approach. So I've taken the liberty of highlighting those two applications on the right, WordPress and Magento. Same kind of approach where users are coming in, getting their requests routed now to the cloud services proxy. So what you'll note here is where there was layer 4, layer 7, web application firewall, and application autoscaling, we've combined all of those key functional components into the cloud services proxy. So the beauty of this is you have one solution here that takes away all the guesswork, the patching, or the interconnects that you may need to do from a port and protocol standpoint of making sure they're consistent as one server talks to another when you have the multi-layer approach. And in this environment, Cloud Services Proxy, we can actually import some of the settings from the ELBs, and now we can introduce the auto-scaling. We have a built-in web application firewall, and we have the advanced capabilities of L4 to L7 load balancing. So all of this provides a very rich functional solution that as our customers look then to scale their applications, they can do one configuration set and then push that down to the Cloud Services Proxy. How we accomplish that is how I mentioned earlier, that the Cloud Services Controller is a SaaS-based solution that can sit within Amazon. It can sit somewhere outside of Amazon. It's really how you want to control and manage the Cloud Service Proxies. And that allows you to have a single configuration that can be pushed to multiple proxies based upon the application nuance. So the beauty of this is you don't need to repeat a whole dedicated set of fragmented software solutions for each application. We have this centralized controller and this proxy that combines all of those capabilities, advanced capabilities, that allow you to simply utilize this solution, and now you're front-ending your application and taking advantage of all those functional capabilities. So that's really exciting to us, because we now are in a position to support these new web scale architectures, these new microservices, and as folks are designing these applications with a container-based approach, we are in a perfect position then to simplify and reduce some of that complexity, whereas in other environments, you may have to do multi-touch, multi-configuration, and even though open source solutions are very good at their introductory or their baseline functionality that they provide, customers want something that's more in line for what their operation teams can utilize in a more efficient manner. So this example that I'm showing here is an vsHAProxy example config, where you have a couple of domains and they have a couple of content requests, one for game, one for photos, and they're going to be redirected to different domains and the different services that they have. And those domains are being load balanced using a round robin rule. So what this actually, as you can see, it's fairly complex from a syntax standpoint. And if you had to configure each instance of a vsHAProxy, you'd have to touch multiple configuration files to manage each individual application. So whether it's WordPress or Magento or what have you, you have to go in there multiple times and you'd have to configure and find your way through the syntax and then enable or disable certain functionality. What I've seen through my 20 years, there's a lot of room to human error. As much as we try to admit that, you can leave in an extra period or a slash or omit a certain character. And now you're troubleshooting this complex syntax rather than just point, click, and enable. So on the right-hand side, what we've tried to strive for is to build upon what the DevOps teams want to have in place. And they ask for API-driven commands, so we have that available. So you can use your existing tool sets to generate some of these configuration changes. Or you can use the GUI, the graphical user interface, where what I've depicted here is similar to the syntax on the left. A couple of IP addresses, you add a couple of ports to it, you select your round robin, and then you can save that. A lot of the things that we see when it's a command line, you have to reload the configuration for it to become active, if you will. On the Appcito interface, once you set your parameters and you hit enable, it's active. So there's no reloading of configurations. If you forget to do it on one of your instances, you may have your application become unavailable. So this is an example of how the complexity can increase, not only from the configuration standpoint, but if there are updates and patches and what have you that you have to adhere to, it can become very complex. So what I'd like to summarize here is there's a better way to do this, to build upon the base level functionality. And one approach is this Cloud Services Proxy with a centralized controller, and then a point-click solution, or use the API-driven approach. With that, the next thing that customers have asked us for is, okay, we get that, the open source solutions did a good job in their first wave of functionality and that we have an advanced layer of functionality, but how can you help me grow with my business? The cloud is all about agility. And a lot of the benefits of the cloud, come with their challenges when using these, the tools that I mentioned earlier in this multi-layer approach. A lot of folks that are going to cloud may be doing a migration. They may be doing a migration from the enterprise or creating new native cloud applications. And these application updates, based upon their cloud architecture, have to be available. I mean, the applications cannot go down. They have to be available for servicing their clients, whether it's an e-commerce or financial app or a healthcare app and so on. So as you do the updates or the modifications, you cannot make them unavailable. You'll be violating certain SLAs. And as you saw with any kind of a complex architecture, you might have to take one or numerous products offline to do the patching, the updates, and things of that nature. So that is not really how the cloud was evolved. It was meant to be online, making these applications available at any time. And this notion of continuous delivery and continuous integration with existing development operation tools is some of the challenges that these existing solutions do not provide. So we've seen that come front and center, as well as the lack of centralized application visibility. So all of these standalone analytics and dashboards that are collecting security metrics or performance metrics or other kind of analytics, they all have to be integrated, and that's another manual step which incurs a lot more overhead as far as labor, time, and cost, things of that nature. So as you start to look at the agility approach or the agile approach in the cloud, Appcito then started to look at how can we introduce our solution to map to what the cloud providers want. That is the enablement of microservices using the container-based approach. And what we've activated here is you can use the Cloud Services Controller to create a policy and distribute that to not only your cloud service proxies within the AWS environment, but in all these other environments that we've depicted at the bottom there, whether it's Azure or CenturyLink or OpenStack. You'll notice that we have our cloud service proxies, or CSPs as we've abbreviated them below, and they can then enforce a consistent set of policies. This is important, very important as you start to go global and you look at the new governance models, the new security postures that companies have to adhere to, whether they're based here in the continental US or abroad, the multinationals. So this allows you to have consistency of policy of your security profile, as well as then how you accelerate traffic based upon time, user, and event. So this lends itself to that agile approach where you're not re-architecting when critical events occur or when critical business applications need to respond in a meaningful manner. So the essential takeaway from this is this all functions as one unit instead of a fragmented, disparate solution. With that, there are certain benefits when you start to take this agile approach. And as I mentioned, as technology evolves, as new capabilities, whether it's containers or microservices or advanced load balancing come into place, or just like HTTP2, where you're now looking at optimizations in how requests are handled, how reduction in the number of connections, and really looking at how you can introduce new ways of application speed or performance, in this case page speed, where you're looking to reduce redirects and really take advantage of these new changes in how applications have evolved. So that lends itself to availability and acceleration. And you can do that in an agile manner, and I'll show you in the next slide how that can be accomplished. That's what customers are looking for. How can I introduce these new capabilities without having to re-architect everything and do multiple touches on all those fragmented environments? Security takes on its own nuance. We often hear about all these threats, and the built-in web application firewall is not a separate component that lives in a different instance. It's built into the cloud service proxy with rule sets that you can tailor and customize for that application or that type of a situation. In addition to the web application firewall, we introduce other security capabilities as far as denial of service prevention, intrusion detection and prevention. We have anti-malware support as well as bot protection. So there's a whole litany of security capabilities that you can enable based upon the type of traffic and the application itself. And rounding this off is the centralized view from the logs and the events that are taking place. You have a centralized view of what's taking shape from a healthcare standpoint, performance, and an analytics. And so you can make decisions and policy changes based upon applications that may be behaving badly or being frequently attacked. You may need a new security posture. So all of these are centrally managed and done in a very point-click manner. One of the things I want to share with you is this centralized view, and I've taken a snapshot of a security approach, if you will, with on the top you'll see response time, the application health, how many block requests. In this case, you'll see a top threat with a slow LARIS. So again, you may not be a direct threat where they're trying to send SQL injections or cross-site scripts. They may actually just want to slow down the way your application responds. So there's multiple threats that we capture, and then we present them in a graphical user interface. And you can see here that we've outlined some bad behaving URLs, some services that weren't behaving well, as well as some client information. What kind of browsers did the request originate from? What kind of operating systems and devices? So you get a real sense of where this traffic is coming from, where the users reside, what's happening at the application level, and what's happening at the infrastructure level. And how is this all responding in line with performance and expected SLAs? Coupled with that, this is the other request that we've got of application maintenance and uptime. When we see continuous integration and deployment requirements with the DevOps teams, they really want to have a very streamlined approach on how they upgrade their application services without having to touch, again, the fragmented pieces that may not support continuous integration and deployment. The term that I use here, or the industry uses, is blue-green, blue depicting servers that are online and active, servicing production traffic. And then the green servers are the ones that are being stood up to then mirror the production application with new capabilities. Maybe there's new patches, security patches, or updates, or taking advantage of a container-based approach. So you want to still make that application available, but what you start to do is to steer the traffic over to the green server. You may mirror it, or you may send a certain percentage just to see how the new application or the updated application on server 3 and 4 are responding. Are they performing well? Is there something that was omitted? So here's a real live way of testing the updates in your application and getting a sense of how the application performed before the updates were in place and how they're doing after. So that's a really useful tool to make sure that we all know that in a cloud environment, there's going to be a lot of new rich features in the applications. There's going to be new microservices that may reside in other availability zones or other clouds. And this is one way of ensuring that those services are available. And if they are not, you can always roll back that capability and double check to see what may have been omitted. So that's really summarizes the agile approach on how users are then attempting to scale as well as map to the ever-changing business requirements. Third, but not least, is cost. As you can imagine, with a very complex and fragmented architecture, which I've depicted on the left-hand side for a single application. This is a WordPress app running on 3 instances. On the left column, if you will, you've seen a high availability of the Autoscale of the web application firewall, whether it's NGINX or vsHAProxy doing layer 7 or the ELBs doing layer 4. And then we have a redundant set to make sure that the availability and any type of traffic spikes or unforeseen events that may take services offline are still available due to the redundant nature of how things are architected. In the table there, I've shown what that current count would be from instances to connections to how many point solutions are in place that you have to manage versus an Appcito solution. As you can see, it's drastically reduced as far as the number of products and how many auto-scaling groups you have to manage. And then the integrated data, we integrate it all within one centralized view. At the very bottom, you'll see the current AWS sample cost. This is based upon some of those instances that I've called out, number of NGINX or HAProxys, the ELBs, as well as the WAFs and the analytic components. And for an annual cost, it's in the range of about $6,000. What you'll see in comparison of an Appcito solution running on an M3 or C3 large instance, it's about $5,444. So a savings of about $600 for one application. What we're not showing here is, imagine if you have a large number of users or a large number of requests and you have to increase that high availability and that redundancy layers for the NGINX or the HAProxys or the ELBs. You have to then double, triple, quadruple those counts of EC2 instances as well as the other layers. In the case of Appcito, we can take advantage of our centralized and combined solution where we do not have to introduce more WAF components, as an example, or increase the number of instances, because we can manage multiple applications from one cloud service proxy. And so as you start to map out application number 2, 3, 5, 10, 20, or 50, based upon your overall cloud approach and how you want to scale, we did the math, and what we saw was as you did introduce more applications, there was significant savings, just along the lines of reduction in WAF components, reduction in instances, and the ability of the Appcito Cloud Services Proxy to handle multiple requests, multiple users, and live in multiple clouds. As you do introduce more applications, when you go into the range of 20 or 50, as you can see that the costs significantly are reduced, and the savings, $75K for 20 apps or $215K for 50 apps. And as you can imagine, as e-commerce sites or other types of sites come online, especially again in the holiday season, the volume of traffic and the number of users increases significantly, and you want to be able to be in a position to scale dynamically, introduce policies, whether you've got users coming from around the globe, and you want to make sure the security measures are in place, and it's all centrally controlled, configured. You can adjust to the business, and then the cost savings make it worthwhile for you to invest in some of these new approaches that are taking shape. So in a summary, what I've touched upon is how to reduce complexity with some of these fragmented solutions, whether you're using the introduction of HAProxy, NGINX, or the ELBs, how to have an agile approach by using the Appcito solution, both the Cloud Services Proxy and the Cloud Services Controller. And the bottom line is you save money, and now you're in a position to really help your business grow and scale as the web technologies evolve. So with that, I'm going to hand it back off to my colleague Bill, and I want to thank you for your time.
Thank you, Das. Very good information, and it's increasingly clear to me and hopefully to everyone in the audience that choosing the right cloud infrastructure really does have the chance to reduce cost and complexity, not by a little, but by a lot. I see many of you have submitted questions to Das, but we are absolutely looking for more. We have time for at least 2 or 3 more than have been asked. So go ahead into that question window in the control panel and ask away. But let me now go with the first one here. Surprisingly, it is about the cost. So the cost savings, Das, for one app, this is according to an attendee named Connor. The cost savings for one app are modest, but grew as he scaled to 10 and 50. Why so big?
That's a great question. It's really goes back to that comment I made regarding the different components that you want to activate. So in the case of a web application firewall, if you want to front end your application with those kind of security protection methods, we don't have to double or triple, quadruple the cloud services proxy to have the WAF components in place. It's really a matter of, let's say you go to 5 or you go to 10 applications. We don't need to double or introduce more WAF layers, if you will. So when you do get into the larger numbers, let's say 20 or 50 applications, that's when you may have to increase the size or the compute power of the instance so we can handle more users. But that's one component. The second component is regarding the analytics. Because we don't have to have all these disparated security or performance or other dashboards that we have to then look into, because they're going to increase every time you have to resize your instances. We have one view, so we don't have to actually incur those costs, and that is an additional saving. So it's the reduction in the number of instances, the reduction in how the WAFs are utilized, and then the analytics themselves. That's how we then compute that calculation.
Got it. Thank you. All right, next question. This is from Aaron. We have apps running in AWS and a private cloud, or excuse me, not a private cloud, a private data center, it says. Does Appcito require parallel infrastructure to manage these two environments?
That's another good question as we look at multi-cloud and multi-apps, where they may reside. And as I refer to, different lines of businesses may have adopted different clouds. And some may have more of a security posture, and others may not have fully migrated their application to a cloud. With that in mind, we architected the Appcito application delivery solution to be multi-cloud and cloud agnostic, if you will. So the cloud services controller, the brains of the operation, if you will, can reside anywhere, but those cloud service proxies can reside in Amazon, in a single zone, in multi-zones, and it can reside in different clouds themselves. The beauty of that approach is that centralized policy can be pushed down to one location, all locations, and based upon per application. Whatever the nuances of that app are, those rule sets and those policies can be pushed down to any one of those locations.
Good. Okay, Mike has a question here, and it had to do with the architecture that you laid out. Why do you break out separate tiers for layer 4 load balancing with ELB and then managing autoscale groups with ELB at a different tier?
That's another good question, actually. That's, as I alluded to, the cloud has evolved incrementally. So just if you think back to the enterprise, there were no proxies or load balancers. Everything came in as the application demands became more pervasive. And that's the same thing that has happened with the cloud approach. As more folks have migrated their applications to the cloud, there's more content and more traffic being driven to these kind of applications. Things have evolved. And what may have been good enough before, whether it was open source or if it was the native elastic load balancer, now they're separating some of those duties because they may not have existed in that product, or they have evolved over time. So you ended up with this multi-layer approach where the initial ELB was doing L4 rudimentary load balancing because it did not have the support for higher layers. Then you found open source software that could do those higher layers, and they were introduced. Then you needed a WAF component because of the threats, and those load balancers did not have a web application firewall. And then there were new capabilities that were built within autoscaling that were not part of the open source solutions or have any notion of autoscale to do, they're not involved with the WAF situation. So now you have this evolution, just like you had in the enterprise, and where and people get accustomed to it, they're comfortable with how they're configured. And this built a lot of cycles and teams to actually manage that. But that doesn't scale, and that doesn't meet the new requirements of how microservices are evolving, how container-based solutions are becoming more pervasive. And so that's where they've looked at a more centralized approach, a more condensed or collapsed approach of functionality and capabilities. And this is all customer-driven. Customers have come to us, the cloud providers have come to us and saying, how can you approach this with a more efficient manner while still providing the functionality and the agility to scale with the business apps. So that's the approach that we've taken, and that's why we're seeing quite a bit of interest in our solution.
Okay, a question from our drone winner, Wahid. How is Appcito reducing the number of instances for an app stack? Is it using larger instances to keep up with the demand?
Well, the application itself is something that we support from an auto-scaling standpoint. So where we are introducing our solution, the cloud services proxy, we are, especially in Amazon, AWS, we are tied into their autoscaling architecture. We actually import the configuration from their ELBs. So the same manner of autoscale for that application, if that application needs to now increase based upon a threshold that you've created, let's say 50% CPU, you have to then spin up another instance. That's just the nature of the application because the demand is so high that you had to increase the availability. Now, we can do that without having to increase our cloud services proxy. We don't need to have another cloud services proxy or increase our capabilities. Now, there is going to come a point where, because of the centralized analytics that we're able to obtain, we can start seeing trends. And if we start to understand that this is a consistent level of traffic, then we can look at our cloud services proxy and maybe start to introduce more CPU or more memory or things of that nature. But it's really having that centralized view and then being advising the client, saying this is the trend, and here's what you may want to introduce from a cloud service proxy standpoint. But that is one approach of how we manage autoscale as well as then dynamically adapt to the traffic loads.
Okay, and our last question for today, Tots, comes from Siva. Amazon allows you to launch elastic load balancers across availability zones and to autoscale them. Can Appcito do the same for their service?
Yes, great question, and that's one of the advantages of having the innate ability to import the ELB configuration and the autoscaling rules, and then have that policy consistent across different zones. You can imagine that some of these open source solutions are not capable of providing those kind of functionality, and that's a real differentiator. And that lends itself to why we use the term advanced load balancer. The vsHAProxy, the NGINXs of the world have done a great job in the initial introduction of their solutions, and they may be useful for smaller environments. But as you really start to migrate and have different lines of business using different availability zones or different geographic kind of rules based upon some of the compliance and regulations I had mentioned earlier, you want to ensure that the consistency of functions is available. And that is something that we support, whereas others do not.
Thank you, Dos. It's time to close up. I would encourage you that if you'd like to check out the products and services from Appcito that we discussed in today's webinar, please call or please visit our website, www.appcito.com. We have personalized product demos, we have free trials, and it's really easy to get onboarded in just a few minutes. So give us a call, give it a try. Again, to reiterate, we will be sending all registered attendees an email with instructions for watching the webinar on demand. And with that, I want to thank you for joining us today for how to slash cost and complexity versus vsHAProxy, NGINX, and ELB solutions. Have a great day.